This is higher, it's Unit 3 NAB practice. What we're going to do is we're going to use some HSN questions from the HSN website. And we've got 3 questions to complete in this first outcome. We're looking at outcome 1 and we've got 12 marks to gain, and 9 of them would give us a pass at this level. Right, so let's go ahead and try this question here. So I've got points A, B and C have these coordinates, and what we have to do first of all is to write down the components of AC. So let's go ahead and do that one, okay? So vector AC is going to be C minus A. When I look at the position vectors, I'm just going to change the coordinates into the column vectors. So C is going to be 4, 1, minus 1. And I'm going to subtract from that A, which is going to be minus 4, minus 3, 1. That should give me 8. That would give me 4 minus 2. And what I can do is I can simplify that out by taking a common factor. That will give me 4, 2, minus 1. Okay? That's part 1 complete. Let's go for part 2. So, show that the points A, B and C are collinear. So what I'll do is I'll pick two of the other points and use one that's common. So I'll go for A and B, the vector AB. Similar to above, I'll go for B minus A. And what I'll do is I'll substitute the values in and work through from there. So I'll go for the component vector for the position vector B. So I've got 0, minus 1, 0. And A is going to be the same as this one that's just up above. What I'll do is I'll just subtract them, and that should give me 4, 2 and minus 1. Okay. Right, so from there what I'm going to do is I can see that these two are the same here, so that will tell me that both of these are parallel. And what I'll do is I'm just going to set up a kind of fraction type ratio, and AC is 2 and AB is 1. It's there. And what I'll do from that is I'll just cross multiply and give me AC is equal to 2 AB. So from that there I can see that they're both parallel. So therefore AC and AB are parallel. Okay. And what I've got is with a common point. And the common point that we used was A between the two of them. So the common point A used, I can then state that A, B and C are collinear. And that's the question complete. So marking for this one here, what I'd get is 1 mark for getting the component vector for AC. I'll get 1 mark for getting the component vector of the other, which will be AB in this case here. 1 mark for comparing them in this form here, and finally a mark for a statement to conclude that question there. Okay, so that's going to be out of 4 marks. Right, let's move on to question 2. Right, so in question 2 what we have is we've got the point R divides S and T in the ratio of 3 to 2 as shown. So what I should have is from S to R will be 3 and that will be 2 there. And what we have to do is to find the coordinates of R. So again what I'm going to do is I'm just going to set up a kind of ratio for this one here. And I'm going to say that S to R, okay, all over R to T, going in the same direction, that's going to be 3 over 2, because 3 to 2 there. What I'll then do is I'll just cross multiply to try and simplify that out. So I've got 2 SR is going to be equal to 3 RT, the vector. From there I'm going to do something similar to what we did in question 1. What I'm going to do is I'm going to put this into its components. So what we've got is I've got 2 times R minus S, okay, and that is equal to 3 times T minus R. And what I'll do is I'll just kind of gather that all together and leave R on the left hand side of this equation. So let's go for that. 2R minus, we've got 2S is equal to 3T minus 3R. I'll bring all the R parts to the left hand side. So that should give me 5R is equal to 3T plus 2S. From there what I'll do is I'll then use the coordinates, and I'll put them in as component vectors in here. Okay, so what we've got here is we've got the component vectors. What we'll go for is 3 times, and we're going for t, so that'll be 7 minus 5, 1. I'm going to add on to that 2 times, and it's going to be s, which is minus 3, 10 and 6. What I'll do from that there is I'll just multiply them out. So what have I got? I've got 3 times 7, 21, 21 minus 6 will give me 15. That's my x component. 3 times minus 5 is minus 15. Minus 15 plus 20 will give me 5. And 3 times 1 is 3. Plus, we've got 8 there. Let's see, that's going to be 2 times the 6 that's there. And that's going to give me 3 plus the 12 will give me 15. Right, from there that's what 5r is equal to. So what I want to do is then I want to simplify it down and work out what r is going to be equal to. So what I've got is it's going to be a fifth. So I'm just going to divide by 5 of this component vector here. So that should give me 5, 1, and that should be, oh dear me, 3, 1 and 3 coming out of there. Okay, and that there should be my components, the components of the vector r. But I've not been asked for the components, I'm asked for the coordinates. So the coordinates of r, and they're going to be 3, 1, 3, because that's just going to be my position vector that's there. Okay then, so let's see where we get our marks for this question here. So I get 1 mark for kind of interpreting the situation like this one here. I'll get 1 mark for working out this kind of area here, for getting the 5r is equal to the component vector 15, 5 and 15. And finally, because I'm asked for the coordinates, it will be the coordinates of r, and must be in coordinate form there, or we kind of lose that mark that's there. So this question here, out of 3, so that's 7 marks so far that we've done. Right, so let's look at question 3. Question 3, 5 marks worth in here. And what we're going to go for first of all is we're going to find LM dot, so the dot product of LM, LN. And we've got the vectors given up here in component form. Right, so let's go ahead and do that one. So I'll do this one up here. So what I've got is I've got the scalar product of these guys, and that's just going to be equal to, and I'm going to multiply the x components, gather up the y components, and also the z components from here. So I've got 3 times minus 2, I'm going to add on to that 4 times 4, and I'm going to add on to that 2 times 5. Okay, so that's going to give me minus 6 here, that's going to give me 16, and this is going to give me 10. Okay, so that's going to give me a total of 20. So that's part A. Right, for part B, what I'm looking to work out is I'm going to use this answer up here to find the size of angle MLN. So if I look at the diagram, MLN, when I'm trying to work out an angle, and the angle that I'm interested in is the angle that's in there, I need to work with the vectors that are pointing away from the vertex, from away from this corner here, and they are at the moment, and I already have the scalar product here, or the dot product, from part A. Right, so first thing I'm going to do for part B is I'm going to set up the equation. Just look at the formula sheet, change the formula around, and what we'll get is we'll get cosine of, let's see, the angle that we're after is MLN. It's going to be equal to, so it's the dot product on the top, so the one that we've already worked out, all divided by, it'll be LM, and it'll be the magnitude of that, and the magnitude of LN. Right, so I know on the top there I've got 20, because I've already worked that out on the top. On the bottom I'll just put the magnitude of LM in, and I'll get the magnitude of LN. So just taking the components of LM, I've got 3, 4 and 2, so what I'll do is I'll go for 3 squared plus 4 squared plus 2 squared. And for the components of ln, I'll go for minus 2 squared plus 4 squared plus 5 squared. Okay. So in that calculation there, what I can do is I can work out that's going to be 9 plus 16 plus 4, that would give me the square root of 29, and this one here should give me the square root of 45. Right, so let's go ahead and work out the angle. The angle MLN is going to be the inverse cosine, and I'm just going to put this into my calculator here, all of this. Either put it into fraction form or make sure that you know how to put that into your calculator to be able to work out the angle. So into the calculator with it, and what we should get out of there should be 56.383. That's going to be in degrees, but I'm just going to answer that one to one decimal place. So MLN, the angle that I've been asked to do, will be 56.4 degrees to one decimal place. Okay, let's see where we're going to get the marks for this one here. So first mark, this one here, we're getting for working out the dot product at the top there. I'll get another mark for setting up the formula correctly. And remember, that's in your formula sheet, not in that form, but just rearrange it into that form and you can get the formula for working out the angle. I will then get a mark for this one. I'll get a mark for that one. So the two magnitudes, I'll get a mark for one of these each, and then finally one mark for my final answer. So this question here is going to be out of 5. So the total there is 12 marks. You need 9 to pass this outcome 1, and good luck. Hope this has helped.